Good morning, afternoon and evening to our global audience today. Welcome to the latest webinar hosted by Device Authority with special guests MultiTech and NextgenID. My name is Rosa Lenders and I'm very pleased to welcome our speakers for today, Adam Eriksson, Richard Stanvik and Keith Sheridan. Adam has over 20 years experience of working for enterprise software companies, building out markets in employee provisioning, encryption, secure credentialing and IoT solutions. He is currently Vice President of Business Development for Device Authority and is responsible for our strategic channel relationships. Richard works with Multitec's industrial Internet of Things ecosystem, products and technologies, ensuring Multitec teams up with the right partners and has the right strategies in place to address and build solutions for real problems. Richard has consulted around security and IoT solutions, built operator and ecosystem relations, managed mobile platform products, marketing and segments, and established new markets and technical consulting. Keith has over 20 years of commercial software development experience and currently serves as Chief Technology Officer for NextgenID. He is a direct contributor to technical products, which includes refining the conceptual architecture for a smart card maintenance system to end-user logical and physical architecture, .NET development, and leading the technical effort to develop and document the policies and procedures for a personal identity verification interoperable issuance system. We expect the webinar to last approximately an hour, and you will be able to submit questions via the chat window in the GoToWebinar control panel. We will try to answer as many questions as possible at the end of the webinar. Contact details are included in the final slide, should you wish to contact any of the speakers directly. A recording of the webinar will be made available tomorrow on the Device Authority website, and everyone who registered will be emailed the link. I shall now hand over to our speakers.
Thank you, Rosa. This is Adam Eriksson with Device Authority. On the phone with us, Rosa had introduced the speakers. The three companies we have represented today is Device Authority, our company, NextgenID, which specializes in credentialing solutions, and PKI, as well as Multitec, which is the leader in industrial gateway solutions. What we're trying to educate everyone on today is how an IoT ecosystem deployment can be built out on a foundation of trust, and hopefully by the end we will have a common understanding of how Device Authority looks at identity and access management for IoT. Today, IoT, of course, is the big buzzword around every industry, and while there may be some confusions on definitions of what exactly is IoT and what are the things, I think we can all agree that every major corporation and government change how they can deliver products and services, as well as increase the operational efficiencies of their businesses. While they're doing this, though, there's great concern about security and safety to achieve those business goals. So for us, the IoT requires a foundation of trust to ensure that the bad things do not occur when these things get open and out into the wild. So we're going to discuss today, how can you form a secure and trusted IoT environment to increase the time to value for a particular solution. What this requires, though, is understanding what is the difference between traditional IAM and device-centric IoT IAM. The core differential is on how now do we talk about onboarding devices and provisioning credentials without human intervention in an M2M world. In a user-centric world, there are nice graphical user interfaces. There are established credentialing procedures. There are ways to tell the identity of a person or a computer coming online. But in a borderless, headless environment, you cannot use these traditional methods. Multi-factor authentication does not exist. In addition, you have the scalability issue. If I have an organization and I have 5,000 employees, that's a pretty big deployment. But now with IoT sensors and devices out in the field, we're talking tens of thousands, 20,000. If I'm a managed service provider, I may have 1 million that I'm trying to help provision out to the field. This cannot be done with humans managing each and every one. Additionally, many of these environments, the M2M is a shared service. So devices are talking to devices. So how do you create a trust environment for that type of scenario? And it's not just us saying that traditional IAM won't work in an IoT world. Gartner and Forrester have called out device authority in our solutions as an innovation in the industry to help solve the IoT IAM issue. They have noted that IoT authentication and IoT IAM are on the growth phase of deployments out in the field. So we feel this is a very timely scenario for everyone to understand what IoT IAM is, why it's important, and why it needs to be built in as a foundation. So traditionally, you take a look and you say, what is the IAM that I'm using in my organization today? Is it enterprise? Is it cloud? Is it an Active Directory schema, or is it from an IAM vendor? Or when I'm used to dealing with devices, do I have hardware modules on my devices that work within an enterprise? And will that scale out into the IoT infrastructure? So this is where device authority as the first device-centric IoT IAM technology is positing that in order to grow to scale a trusted environment, that we have the unique solution that's market ready today. So with that, I will hand it over to Richard from Multitec. Richard?
Thank you very much for that. Rich Stanwick is my name. I work at Multitec dealing with our partners and the ecosystem. And I'm going to talk a bit about, first of all, what we do, and then put what we do in context for today's discussion here. So Multitec, we've been around for quite a while, 46 years in the making here. We've been doing connectivity technology all the way since analog technology was in fashion. So we have a product portfolio of ability to connect the end device, the sensor or the actuator in the field using wired or wireless technology, both in the licensed spectrum arena as well as in the unlicensed spectrum area. Cellular technologies ranging from 2, 3, and 4G all the way to NB-IoT. Unlicensed spectrum technologies like LoRa and LoRaWAN, and components also in the core network for device management, etc. So we basically provide the equipment that sit out in the field that allow cellular or LoRa, or for that matter wired communication, back to the cloud where device user security and applications management happen. I should also perhaps mention that we have horizontal presence that ranges from manufacturing, industrial applications through energy, monitoring, healthcare and agriculture to connected city, and quite a few other verticals as well. The dominant deployment of our technology today we see in the 4 verticals shown on the screen. And there's a quite substantial range of companies using our devices there. We would count to roughly 25+ million devices of Multitec's making in the field right now. Can we go to the next slide, please? Thank you. Can we move forward? Thank you very much. So if we look a little bit at the market then, classical IoT, or should we say consumer-facing solutions versus industrial-facing solutions, they differ in a few key areas. So when you look at the left side, consumer-facing stuff, we want low cost, we want high volume, and you can normally address a large chunk of the market with, if not a one-size-fits-all, then at least one-size-fits a substantial chunk of the market. It's not necessarily hardened towards the environment. Product life cycles tend to be short, etc. Whereas if you look at industrial-facing solutions, and that's where we basically play, we see security as a key requirement. With that comes reliability, ability to control, and well-defined control points. Little or no human intervention, and this is key because this costs money. The environmental factors are imperative. You need to construct a device that lasts for a long time. Long product life cycles, industrial applications live for a long time, and ability to provide data with high quality into select enterprise systems. It's also worth pointing out at this point that there are various modes of deploying a communication architecture here. We have public networks. Here we find, for instance, cellular deployments through various operators around the world. We also have enterprise and private deployments where a organization or even individuals are setting up network. And these topologies have different characteristics when it comes to CapEx, OpEx, mobility, speed of deployment, manageability, etc. And we will touch a little bit on that as we move forward. Next slide, please. Just to exemplify this and to show a value chain, here we are just illustrating how the typical topology might look, in this case instantiated through a LoRa scenario. On the left, end devices and actuators in select verticals, enabled through various communication technology. In this instance, the end devices speak LoRaWAN. In the middle, you will have a radio network of some shape and form, in this case, LoRa gateways from Multitec. This connects back to a cloud-hosted set of management platforms where you do device management, security management, etc. And on the right side, you would have your data visualization and data management side of things, where we would interact with big players who normally specialize in these areas. We can do the next slide. We're going to overlay on this a few of the security components that we are looking at now. So we have control over some of the devices in this architecture, not all, but some. And we are now aiming at basically ensuring that our offering in this architecture is secure by equipping the devices with the right technologies and the right enablers. We also need to ensure that our offering in context works so that data can flow securely from one end to the other. And that means that our partners' solutions here needs to have elements of security, and also, equally important, the communication links need to be secured. And finally, we need to have an ability to partner with suppliers of, and then go to market with, select services. And this is where the real value comes, because this is where we can both provide elements that we can monetize in the market, and this is also where we can create real value for the customers. So if we just take a little look at the areas of enablers and services where we are now looking at doing both technical and also market work. We have today in our devices various enablers for secure space. We have a secure element in our LoRa end device module. We are looking at putting a trusted execution environment, virtualization concepts, etc., into the gateways and other components here. On the link side of things, both LoRaWAN and cellular communication are inherently secured, 128-bit encryption in LoRa, providing dedicated network and application data types, for instance. We need to ensure that we have access security, policy management or rule book that guides the authorization process. What devices and applications and users shall and shall not be able to do. We need to cover the operator-specific requirements, their need for secure credentials management in SIMs as they exist today, in eSIMs, i.e. reprogrammable SIMs that are basically provided to the device at birth, both enabling multiple operators to target a device and also saving cost by removing the need for a replaceable SIM. And ultimately, as we move forward, we can assume that this construct will go into a software solution protected by a suitable secure space enabler in the device. We also need to look at device integrity to ensure that the device at any point in time is in a known and predefined state. Thus, secure boot is of essence so that when the device fires up, we know how it fires up. A watchdog or similar functionality that ensures that during the device life, nothing bad happens to it, potentially governed by the policy machinery. We need to provide hardware or tamper resistance to ensure that if somebody attempts a physical intrusion attempt on the device, well-defined action happens. For instance, the device shuts down, or there might be a kill switch or similar. Now, once we have a subset of these enablers in place, we can start to provide valuable services. And here we come into the reason for the engagement here today. We're going to talk a bit about what these services are and how they can be deployed over a communication network. And we're talking about services like provisioning, ensuring that we can provide, and for that matter, de- and re-provision devices and applications as well, with credentials, with keys and certificates. We need to have an ability to encrypt data, both while it's in motion and flowing from the end device to the cloud, but equally important also while data is at rest, when it lands in a gateway or in the cloud, that it can only be accessed by and touched by the owner of that data. We need ability to authenticate both devices as well as applications and users across this network so that we can trust the device or the user. Authentication is, as we know, the process of verifying that something is what it says it is. We also need authorization mechanism, and authorization here means, are you allowed to do what you are claiming you want to do? Again, we need to be able to, through policy management, authorize devices, applications and users, and also say no to certain activities. We need to provide a mechanism for firmware or operating system update to ensure that the devices are always up to date in the field without having a need for a truck roll or physical access to the device. And we need to provide manageability, ability for a user, or for that matter a service, to manage the device, to verify that it is where it says it is, that it does what it's supposed to do, that it is up to date, etc. And the same applies to the communication link and the users. We need manageability. And normally this is instantiated as a console of some shape and form, normally living in the cloud. And this, again, is where our Device HQ platform comes into play. This is exactly what that does. Thanks for shifting slide there. A few words on Device HQ. This is our device management tool, and it does what you would assume it does. It allows us to basically access the device, check what the device is doing and what the output from the device is, and also to push certain select information to the device, i.e. a way to remote control the device. Now, an interesting component here also is the application store and the ability to manage applications. We are now offering an application storage facility where developers can basically publish their applications. And this is, as far as I know, a quite unique feature. It is not necessarily just meant for public consumption, but also for internal consumption in, say, an enterprise scenario where you want to deploy a well-defined set of applications to be utilized in a well-defined part of the network. Now, Device HQ is also the mechanism with which we are interfacing with partners, like our partners here today, and through which we will expose some of the value-added services that we are talking about here. And with that, I would like to hand over to Keith.
Okay, thank you, Richard. So just as a brief introduction to NextgenID, we are an enrollment services and credential issuance company. We issue credentials in the smart card format, including high assurance credentials known as PKI cards. We also operate a PKI, which we are in the final steps of becoming cross-certified to the U.S. Federal Bridge. This means that the usage policies in our certificates are mapped to the federal PKI policies. And the certificates that we issue can be validated up through a chain of trust to the Federal Bridge CA. Our company has extensive background in biometric and IT security, and based on this, we have developed an enrollment kiosk which captures a person's biometric and identity documents to support the identity proofing required to issue a certificate. Okay, next slide, please. So just a little bit about what is PKI. So one way to think about what PKI does is that it binds the public key to an entity, and that entity could be a person or a device. And then a relying party is able to determine how much it can trust the certificate based on the policies of the PKI that issued it. So for example, if you're trying to decide if you can trust one of the devices that Richard was just talking about, you can set up based on your organization's rules what policies you want. Given the number and types of different devices that are out there in the field, it is critical that the appropriate level of assurance certificates are used. Then briefly about certificates. Some of the relevant fields in a certificate include the subject. So that's identifying the device or person that it's associated with. It's the validity period. So the policy may require something is revalidated every 2 years or 3 years. So this is a way that you know the certificate's still good to the policies. It also specifies policies related to its
Muted.
and usage, so that a relying party can know what it can do with the certificates and under what policies it was issued. Of course, it has the public key information, and it is signed by a trusted CA, so you can establish a chain of trust. Okay. Next slide, please, Adam. Okay. So one of the things that we've observed is that there are a lot of bad PKIs, and it's done usually in order to meet the internal needs for certificates that are at a low cost and something you can get quickly. So to meet that need, some companies, or even within a company, a given department or an individual administrator, will create an internal PKI. And one of the reasons they do that is it's technically very easy to do. For example, on a Linux system, you can create certificates and sign them with OpenSSL. In a Windows environment, the Active Directory certificate services is very easy to enable. The problem is, without the controls and policies that are understood and accepted between different organizations, you're not going to have the interoperability that you need. So you could get in the situation where two different departments of the same company can't trust the certificates issued by each other because they don't really know what the rules and standards that were followed. We know some anecdotal stories about some major companies that issue internal certs from, maybe it's a PC underneath an administrator's desk, or maybe it's at his home because he, happened to have an extra computer at home or something like that. Another case we know of was a company that had about a dozen different PKIs, and there was no interoperability between them. Generally these things are done not really for malicious reasons, excuse me, but to get something going quickly and cheaply. But there's some, potential consequences to what could happen in this scenario. For example, what happens when one of these administrators leaves the organization and, the CA was on his, in his basement? Or what if you actually did have a malicious administrator, and they did something wrong intentionally. So the real bottom line is when you have bad PKI, it can lead to really bad things. Okay, Adam, can you go to the next slide, please? So what is a solution to these issues? One solution is a managed PKI service like the NextgenID offering. This solves the problems from the previous slide by doing things with systematic and transparent methods. For example, we publish a certificate policy, which among many other things specifies the level of assurance for certificates, the rules that were used to prove the identity of the device or person, and the security controls required for the CA equipment. So this allows a relying party to look at a published document and decide how much trust they can put in a given certificate. The CAs and the PKI are governed by a policy management authority, the PMA. The PMA is a formal body, and it votes on changes to policies and most importantly publishes those updated policies so that the current policies are always available in the repository. The CA itself is managed by an operational authority, which includes trained staff, and that's important that these are people that have been trained, had background checks and that type of thing that are needed to operate the CA. The managed service, excuse me, the managed service includes all the logical and physical security controls dictated by the published policy and includes features like key escrow. So that's very important if you have data at rest that was encrypted and then you need to, 5 years later, you need to be able to access that encrypted data, but the certificate's no longer available, maybe because the device failed. Another really important aspect of a PKI is proper lifecycle management. When a certificate is close to expiring, you need a method to ensure that it is properly renewed, and maybe it needs to have its identity of the subject revalidated. Another aspect is for revocation. So if there's a reason why you've decided that a particular device or person is no longer to be trusted, either because something failed on it, something bad code got injected to it or something, you need to be able to revoke it, and also very importantly publish its revocation status so that relying parties know it's no longer something to trust. So all of these things that I've been talking about, the policies, the procedures, day-to-day operations are all verified by an external auditor who performs an annual operational audit. And that audit confirms that the written procedures are consistent with the policies and that the day-to-day operations actually follow the written procedures. So the final point I wanted to make about the managed service is that the cost of operating the PKI are lowered because infrastructure and personnel costs are shared across multiple customers. And finally, it is the primary focus of our company, allowing us to have greater expertise in the policies and procedure and operations of a CA. Thank you.
All right. Well, both Richard and Keith, I appreciate you detailing some important aspects. And I think, speaking briefly to both of your comments there, whether it's different PKI infrastructure inside of a corporation or if it's different IoT rollouts, one thing we definitely are going to discuss in the upcoming device authority slides are the fact that we want to unify a policy that controls the security posture over these devices so that the root of trust is established as per a company security policy and not just by a single individual in a single department. So I think as we start talking about the synergies between the three companies, this is something that we do. But for those of you who may be new to device authority, we are an enterprise software company. We have strong patents in the space that we're talking about. We can be run in the cloud or on-prem. While we ourselves are not a cloud provider, we were announced 2 weeks ago as a premier AWS SaaS partner to support SaaS contracts from AWS. We work with OEMs such as Multitec, CAs such as NextgenID, managed service providers, and system integrators. So our go-to-market is definitely through leveraged channel partnerships. So here we've come to the key aspect when we talked about the big change in IoT is identity. How do you create a unique IoT device identity? And this is where we start getting the difference between traditional IAM and IoT IAM. For an IoT device, you need to be able to create a trust anchor. And that trust anchor then must be allowed to operate through the different layers of authentication to provide the authorization to ensure the integrity, privacy, and policy management to additional applications and services or devices. So device authority being the first device-centric IoT IAM technology, our Keyscaler technology is able to be loaded onto a device, and it can take the attributes of that device to create a unique identifier. Those unique attributes, we call the entropy of the device, are critical as we create the root of trust. Because if those attributes ever change, our system will alert and allow the operator to know that something has happened to that particular device, and that trust has to be verified. So that device could be quarantined. So while our agents are very flexible for IoT IAM, the fact that we're also able to expose via APIs and SDKs to additional applications and services, we allow then that initial trust anchor to be extended across your various IoT applications or your various IoT devices. The flexibility is core because within the software package, as Richard and Keith had mentioned, the ability to update and the ability to easily deploy becomes a critical factor in the scale of IoT. So again, when we talk about device-centric IoT IAM, we always come back down to that trust anchor. How do you create it? What technology can you use to create that unique identity? And then how do you manage that at scale and to policy? So we take a look at which stage can the device authority technology create that trust relationship. So in the IoT device journey, we start with an OEM or an ODM. And today we're working with Intel on their EPID and Marshall Point cloud service where they want to do zero-touch provisioning of devices. So should a manufacturer, gateways, camera manufacturers, other sensor manufacturers wish to build this trust anchor in from the get-go, we can work with them at that stage to make that a silicon layer trust anchor. But as these devices go through their sales channels, either to distributors or resellers, they can also then decide if they want to load on our technology to be able to provide that as a value add out to their customer sets. Or finally, when there's an actual owner of a device that receives it. And this is critical because while we talk about a Multitec gateway, in reality, an industrial IoT deployment has 30 different vendors. So that owner wants to deploy a single security technology platform such as ours to create a single security posture and not just rely upon the security password of 30 different vendors or a certificate created by 30 different vendors. So they may want to load us onto their systems and once again, using that trust anchor, tie that into their IoT platforms and applications to ensure the integrity and trust of that data as it's going through the chain. Finally, should they want additional layers of security, we can help them automatically by policy whitelist and provision PKI credentials down to multiple devices in a single-click fashion. And more importantly, as Keith was talking about with PKI credentials, it's extremely important to know what your policy is, not just for provisioning, but for additional management. What is your rotation cycle? What is your revocation cycle? And so by using an automated platform such as ours, and by binding that certificate to a specific device, we allow that to happen in a very economical fashion at scale that is not reliant upon a human intervention that can create not only a backlog, but with human intervention become human errors. So when you're able to automate, you can eliminate that risk. To take it a step deeper, all the experts now agree that a subset of IoT IAM is PKI provisioning for IoT. As we take a look at this slide here, we're talking about the standards that are being set in an industry. And once again, we talk about the automation of the process per policy. So the first step is securing IoT devices with the PKI certificates is being able to determine what your PKI CA is, where it is, and be able to, as you deploy devices, auto-provision them with a registration control that will go get the certificate, bulk load it onto a device, and once again, using the whitelisting, automate it, but use that device authority trust anchor to bind that certificate to that device. So it is a unique identifier for a device. This prevents the botnet attacks that will take over one certificate that has been provisioned to multiple devices out in the field and be able to do malicious actions with that. The owner-controlled PKI is extremely important because the organization, and it can be a smart government, can be a healthcare system, they have to have a single security posture from their organization dictated by policy that goes into regulation and compliance that they manage. They cannot rely upon multiple security policies from different manufacturers that they cannot control in a simplified fashion. So the policy PKI-driven management becomes a critical foundation in any IoT IAM discussion. And finally, it's that understanding of, once again, how do you create that unique IoT device identity? What technology can you do to use it? This is where device authority and our IP have established a very unique way to do it, which we believe as device-centric IoT IAM is fundamentally not only different from traditional IAM, but it's the only way to create that unique trust anchor. While we believe that a lot of these benefits are very evident in IoT deployments, in reality, as we all take a look at the subject matter of IoT IAM, and as we said in one of the initial slides, trust has to be a foundational element of an IoT deployment. Because what we're talking about here is not just security, and it's not just monetary, as recent ransomware attacks have proven that I can take over IoT devices to control industrial robots until I get paid to go away, but it's a safety issue. If I take over the specs on an industrial robot that is making consumer goods, and I alter the specs by a couple of millimeters, and my production line is not able to catch that error, when those end products get out into the field, that could create a public safety issue. And if I am running a smart city project, and all of a sudden something happens to my streetlights, then that creates a public safety issue. So the ability to create a unified IoT IAM policy, the ability to create that trust relationship from the device back on up into the application layer, and the ability to automate that as per a policy, not only makes it a very secure, robust IoT implementation, but it also safeguards it as it goes to the future, adding in new IoT devices, and extends beyond the applications that are available today. And this is as organizations are investing into their IoT deployments, they cannot just be thinking about what are the requirements today. They have to imagine what are their requirements in the future. So as a software technology, we feel that we are very well equipped to go and to handle not only these current requirements, but to build the trust of the future requirements, whether it be coming from an application enablement platform, an industrial sensor, or a connected car use case where the cars themselves are talking not only to the owner of the car, but cars are talking amongst themselves in a shared learning environment. To show you a commercially ready deployment use case today, again, we're not talking about future products, we're talking about what is commercially available today. So in this use case, we have a Multitec gateway, and we have PKI vendors and private certificate authorities as well. So our Keyscaler technology platform sits in the middle and also sits on the device. So while we're showing a Multitec device, this could be an IP-enabled camera. This could be a different sensor device on a medical imaging machine. So initially, to create that trust anchor, the device gets whitelisted. It has our technology running on it. And as it boots up, it phones home to do an initial device registration. So our Keyscaler platform says, okay, I see that you are phoning home. You are a registered device. You do have the unique identifier, the unique trust anchor. So therefore, I accept you as a trusted provisioned device in the field. Now, as part of the security policy over this, the organization wants to provision a high assurance next-gen PKI certificate. So now that the trust anchor has been established, our Keyscaler platform phones out to the NextgenID managed service and says, I need to provision this certificate out to this device or to these devices. So working with the NextGen platform, the certificates are signed, sent back to our Keyscaler platform, which then delivers them, kind of like a secure FedEx model, back down to the device. And once again, using that unique identifier of that specific device, binds that certificate to the device. And then on an ongoing basis, as per security policy, that device can be authenticated back to the Keyscaler platform on an hourly basis, a weekly basis, a yearly basis, and those certificates can be, once again, rotated on a required basis. But also extremely importantly, if something happens to the entropy of that device, if malware is loaded onto it, that unique identifier, that root of trust will change, and the Keyscaler platform will automatically quarantine that device and alert the operator for triage. So with all of the Mirai botnet attacks that are going out and about, where people do not know whether their device has been affected, if it had been using the Keyscaler platform, the operator would be immediately alerted and the threat could immediately be quarantined. So this is something that we are very excited to help IoT implementations out in the field. We do believe that that security policy management is a core function of any IoT IAM implementation. And again, since we're dealing from the device back on up into the application system, we feel that that's a far more secure methodology of trust than trying to extend a directory schema of ownership over to a device and claim that that is now IoT IAM. So with that, we're going to do some Q&A, and then following the Q&A, we would like to alert you that should your organizations wish to purchase a Multitec device for testing in conjunction with Device Authority, you can contact Richard. Should you wish to try out our Keyscaler system, once again, you can go to our Amazon marketplace. We do have special POC SaaS contracts for available. And then also, if you wish to engage with us on further discussions, we can arrange for a additional sandboxes to be set up for virtual device testing, should you wish it, and should you wish to provision the NextgenID certificates. Certain Keith and crew will be more than happy to work with you there. So with that being said, Rosa, I will let you direct the questions to the appropriate participants.
Great, thank you, Adam, and also Richard and Keith. I've been sort of monitoring the questions, so I'm just going to go straight in and start with one for you, Richard. So IoT security is a big topic. So people have been asking, sort of which security technologies and services do you believe will have traction in the market now, but also in the future?
Right. So I think I would like to go back to the slide I talked about. I mean, we have a bunch of technologies that we are now looking at supporting in devices, in end devices, in gateways, and in the various components that sit between the end device and the cloud, and to some extent actually also in the cloud platform. We are talking about the ability to provide secure space, either for application execution or for data handling. Now, this can take the form of, say, a secure element that you have in your end device for storage and management of keys. That would be your SIM in a cellular connected device. It could be a dedicated secure element in a LoRa connected device, or a device connected using another technology. Now, that is kind of a bare minimum requirement at this point if you're looking at a secure way to managing those keys. As we move forward, we can see that the services we talked about here, authentication, authorization of policy management, the ability to provision a device, update the firmware, etc., and also to provide end-to-end encryption, both for data in motion and at rest. These are all value-added services, and we are starting to see requirements for these services as we speak right now. Then you can argue that as we move forward and the market matures, we're going to see more awareness in industry verticals. When you deploy your use case, at that point, that's the time to do proper security assessment. Because what we should bear in mind is that there isn't a one-size-fits-all solution here. Excuse me. The security requirements for an agriculture use case varies widely from security requirements for, say, an e-health use case. The treasure you want to protect, or the asset you want to protect, has different value. So that analysis needs to look at how valuable is my asset, how much am I willing to invest in the protection of that asset, and also, correspondingly, what do I do if something goes wrong? If I have no protection and the asset goes astray or is compromised, how do I then come back up? How do I resolve that issue? That needs to fold into a business case that justifies the investment that you will have to do in security. So, just to go back to the question, today, I think we are seeing, as we said, the secure space together with some select services appear on the radar already now. But as we move forward, more services will come, more requirement for device integrity, more requirements for policy management will appear. Thank you.
Thanks, Richard. I've just got another question now. I'm just going to ask for Keith. Keith, I've had a question. Do you see government IoT deployments requiring different levels of certificate assurance, or is it will one level fit all?
Yeah, I think there will be different levels. Similar to what Richard was just talking about, the agency would have to evaluate the value of the particular device that was being authenticated. Also looking at things like if the device was encrypting data, you'd have to pick a policy that included key escrow. And if you take Adam's example of the industrial robot, if it could be modified to create a life and safety issue, then you need a much higher level of authentication and verification of the device's identity and the authentication requirements for it. Thank you.
Thanks, Keith. Adam, I've got a couple questions for you now. So firstly, what devices does Device Authority currently run on / support?
Currently, we have been tested on many different platforms. We have certain customer sets that are commercially up and running today that have their own specific chipsets and firmware, and they have used our agent to be able to bake into their process. But more importantly, out in the open market space, we run on a lot of the open platforms. So as I mentioned, the Intel chipsets. Today we work across a wide variety, and as Intel launches their EPID Marshall Point service here in the near future, any device that has that chipset is automatically provisioned with our Keyscaler interoperable with that. We also have ARM-based chipsets which we work on, which in the industrial space has been a critical thing since 90% of industrial use cases and gateways are using ARM-based chipsets, much like Multitec. So today, we have not yet met a device we have not been able to load on to create that trust anchor. So if someone has a device that they're wondering if it would run or not, again, they can contact us, and we can run it through its paces as well as check out what the performance metrics will be and everything else.
Okay, great. I've just got another question for Adam. It's asking about the provisioning process, and being secured on the device side. So it's just asking how that works, granting that no one is able to read out the authentication element as it's traveling from the platform to the device.
Well, that has to do with our patented technology. It's called the dynamic device key generator, which is as the agent gets loaded onto a particular device and as per policy takes that level entropy from the device to create that initial key. That key in and of itself is not sent back to the Keyscaler platform, but rather it is a challenge and response. And since the device has been whitelisted, the Keyscaler platform knows what the challenge response mechanism will be. And so as long as it receives the proper identifier of the entropy of the device, that trust anchor, then it will be a secure provisioning. So there is no man-in-the-middle attack. In a lot of environments, if a device already has a TPM on it and they want us to use that for additional security, we can do that. But also it's critically important in a lot of these IoT environments, and I think Richard can attest to this, is that with a lot of the devices out there, they're not going to be launching a TLS session every time they're going to communicate. So you need an ability to be able to provide that secure trusted authentication in a very lightweight fashion, especially if you're doing satellite links or other cellular links where the data load will be very hefty. So for folks that are more interested in that, we'd be glad to have the dialogue. We do have quite a bit of collateral on our website, both written collateral, technical collateral, and a variety of webinars such as this and other short videos that go in depth and explain. Recently we launched we have a Dell reference architecture supporting access cameras. So that piece of collateral is on the website, and that goes through basically how this whole process works for your consumption on an as required basis.
Thanks, Adam. I think I'm going to sort of close the Q&A there, but I really just want to say thank you for everyone else's questions that we haven't actually been able to answer, but we will answer them individually, hopefully by early next week. So we've now actually come to the end of the webinar, and again I just want to say a big thank you to our speakers, Adam, Richard and Keith, and also to all the attendees. We look forward to engaging with you further, so please do not hesitate to contact us. All the details are on the slide now, and of course we will send out a recording of the webinar tomorrow. Thank you.